You are looking at a shelter mounted on a 3/4-ton truck. Both are standard United States Army equipment. The shelter is small and compact, but big enough for its purpose, for it houses one of the smallest radio teletypewriter units available for tactical communications. Let's look inside. The combination of components you see mounted on the wall carries the nomenclature AN/GRC46. The objective of this film is to acquaint you with its components and provide you with an explanation of the electronic function of each component. We'll also outline the capabilities of the AN/GRC46 and show it in operation. First, the components. The ideal way to study the components of the AN/GRC46 would be to assemble them one by one, so we'll do just that. We'll mount the components on the rear wall of the shelter. This balances the weight on the vehicle and maintains the desired compactness so that the controls of each unit will be accessible to the operator. For sending and receiving teletypewriter messages, we'll install a teletypewriter set. The ANU-GC4, which is commonly called the page printer. To increase the flexibility of teletypewriter communications, we will install a second teletypewriter. This one, the TT76, is commonly called the reperforator transmitter. It will enable the operator to record messages on tape and use the tapes for later transmission. Next, we will add radio equipment for transmitting and receiving the teletypewriter traffic. The transmitter we will use is the T195. The transmitter will also provide us with voice and continuous wave communication facilities. Next to the transmitter, we will mount a receiver. This is the R392. It will receive voice, continuous wave, and frequency-shifted keyed signals. The electronic signals provided by the teletypewriters are incompatible with the radio equipment. Therefore, we will have to mount two additional components, utilizing the space in the upper right. The first of these is a radio transmitter modulator, the MD203. The modulator electronically converts the DC teletypewriter output impulses into frequency shift signals so that it can be transmitted by the T195 transmitter. The second required unit is this frequency shift converter, the CV278. The frequency shift converter converts teletypewriter traffic into DC impulses electronically so that it can be fed into the teletypewriters. We'll discuss the electronic functions of these units in more detail later in the film. All the units we've installed thus far require electrical power for operation. 28.5 volts of direct current are required for the radio equipment, the transmitter, receiver, modulator, and converter. The teletypewriters require 110 volts of 60-cycle alternating current. The initial power source is, of course, the vehicle's battery. The battery supplies the power to start the engine. The engine drives an alternator. The alternator provides approximately 28 volts of three-phase alternating current. The alternating current output of the alternator is fed into a rectifier and filter system, which converts it to approximately 30 volts of direct current. After being fed through a voltage regulator, the 30 volts of direct current is suitable for operating the radio components of the AN/GRC46. It also has two other purposes to serve. First, it must be converted to the 110 volts of 60-cycle alternating current required by the teletypewriters. To accomplish this, we need one more piece of equipment. This piece of equipment is a motor generator, commonly called a rotary converter. And finally, after a voltage drop, it is fed back to the vehicle's battery for recharging. We would like to point out here that another component is provided. It is the interconnecting box J1195. Used in online crypto operation, it is mounted on the shelf just above the floor. Two converters are provided, one in use and one spare. They are mounted on the floor. We now have assembled the important functional components of the ANGRC 46 and provided some of the required power supplies for each unit. Here are some of the accessories used most frequently. This, the leg key KY116U, the loudspeaker LS166U, and the microphone M29U. Another device we will need is this interconnecting box J668. It provides the receptacles, terminals, and interconnectors needed to electrically combine all the components of the ANGRC 46. The front panel of the interconnecting box includes power meters, various power off-on switches, fuses for the rotary converter and other circuits, a function selector switch with controls, and main power circuit breakers. In addition to providing complete interconnecting facilities, the J668 also functions as a master power control for the ANGRC 46. This component must be readily accessible, so we'll install it here, between the teletypewriters in easy reach of the operator. Another device we will need is this three-position send, mark hold, receive switch. It controls the function of the teletypewriters. The send position connects the teletypewriters for transmission. The receive position connects the teletypewriters for reception. The mark hold position places both the page printer and the reperforator in a holding condition. To the right is the tape distributor control switch for use when operating crypto equipment. We can now complete the installation by making all the necessary cable connections. This ANGRC 46 is ready to begin operation. We've seen and installed each component of the ANGRC 46. We will now examine the electronic function of the transmitter, receiver, and teletypewriters and see how the modulator and frequency shift converter make them compatible. This explanation will be simplified, but it will be fundamentally accurate. The transmitter generates what is called an RF signal, which we will represent with this wavy line. If we were to examine a portion of this RF signal, we would find that it has two characteristics. It has frequency, represented by the distance between these 2 points, and it has amplitude, represented by the distance between these 2 points. Since it is this RF signal which is eventually sent out over the airwaves, we must add to it any information which we wish transmitted. One method of doing this is by shifting the frequency. Notice that these distances are now changed. A second method is by varying the amplitude, the distance from top to bottom. Notice that now the distances between the top and bottom peaks, which represent amplitude, are varied. This signal now has varying amplitude. Now let's examine the signal provided by the teletypewriter. We'll let this line represent the output of the teletypewriter. When the teletypewriter keys are operated, or a taped message is fed into the reperforator, direct current impulses are created. These impulses represent current flow, but in reality, they will not be as orderly as this, for the various letters and symbols of the teletypewriter machines create various combinations. Like this for letter T, or like this for letter R, or like this for letter B. So we have an output signal containing various combinations of DC impulses, a signal that accurately represents the message typed on the teletypewriter. The teletypewriter output signal of DC impulses must shift the RF carrier frequency of the transmitter. The modulator performs this function. Both the RF signal from the transmitter and the DC current impulses from the teletypewriter are applied to the modulator. The modulator produces a shift of the RF frequency for each current pulse applied. This is the result, an RF frequency-shifted signal. Every time a key is pressed on the teletypewriter, DC impulses are created in the teletypewriter's output. In the modulator, these same impulses cause the RF carrier frequency of the transmitter to shift in frequency. This signal has been keyed by shifting its frequency. Thus, the process is called frequency shift keying. In the transmitter, the signal is amplified and transmitted. When receiving teletypewriter traffic, the process is reversed. An RF signal containing the teletypewriter information in the form of frequency shift keying is picked up by the antenna and fed into the receiver. From the receiver, it goes to the frequency shift converter. The converter reverses the actions of the modulator. It utilizes the frequency shifts in the RF signal to create DC impulses, which are fed into the teletypewriter. The DC impulses operate the receiving teletypewriter, which then duplicates the teletypewriter traffic transmitted by the distant station. We use this radio frequency carrier signal to send voice and teletypewriter messages at the same time. Since teletypewriter communications varies only the frequency of the RF signal, we can utilize varying amplitude to carry voice communications. Both variations can be carried at the same time. This allows the ANGRC 46 to offer the feature of simultaneous voice and teletypewriter operation. Now that we understand the electronic functions of the equipment, let's examine the capabilities of the ANGRC 46. The frequency range of the T195 transmitter is from 1.5 to 20 megacycles in 10 bands. The transmitter has an automatic tuning feature, which allows up to 8 channels to be pre-tuned. This allows fast, efficient tuning of the transmitter. The frequency range of the R392 receiver is broader than that of the transmitter. It operates from 0.5 to 32 megacycles in 32 bands. Unlike the transmitter, it has no automatic tuning feature and must be tuned manually. 3 types of service are provided by the ANGRC 46. Continuous wave operation using the hand key. Voice operation using the microphone.
Logistical support. Request this command. Delta Alpha 211/36.
Teletypewriter operation utilizing the page printer. Or the reperforator. And as we learned earlier, simultaneous voice and teletypewriter operation. Simultaneous CW and teletypewriter operation cannot be obtained. The tactical range of the ANGRC-46 is measured in terms of the ground wave. The ground wave follows the curvature of the Earth and provides a reliable range of approximately 80 kilometers with the ANGRC-46. This distance is given in approximate terms because it will vary according to terrain and atmospheric conditions. In addition to the ground wave, there is a sky wave component, the signal radiated by the antenna being reflected by the ionosphere over long distances. The sky wave range is subject to many variations, depending upon the conditions of the ionosphere, the terrain, the operating frequency, and the type of antenna system. Average sky wave distance is over 1,600 kilometers, but it is not generally used for tactical purposes. Some of the capabilities of the ANGRC-46 are determined by the antenna system. The antenna provided is a 5-section, 15-foot whip. It is mounted high on the outside front panel of the shelter. Inside, it is connected directly to the transmitter. When only one antenna is used, there is an additional interconnection between the transmitter and receiver. This jumper allows the antenna to be switched from the transmitter to the receiver and vice versa. Thus, the one antenna serves in both transmit and receive. What we see here is called half-duplex operation. Traffic can be transmitted or received, but not simultaneously. For duplex operation, a second antenna is required, and it must be located at least 15 meters from the first antenna. Additionally, the transmitter and receiver must be tuned at least 1 megacycle apart. For duplex operation, cabling changes which require higher echelon personnel are necessary. Due to antenna requirement, duplex operation while mobile is not possible. Other capabilities of the ANGRC-46 can be seen by watching it in operation. We'll assume the operator has a high priority message for an air-ground liaison team. First, he checks the frequency, call signs, and authentication. Then he checks the channel band frequency chart. This tells him which channel has been pre-tuned to the frequency he wants. In this case, it is channel 6. He turns the preset channel selector switch to channel 6, and the transmitter is automatically tuned to the desired frequency. Since this is to be a voice call, the service selector switch must be set to the voice FSK position. This position is for radio telephone and/or radio teletypewriter transmissions. The other positions are standby, used to conserve power when not actually transmitting. CW, used for continuous wave transmissions. Calibrate, to provide a means of tuning the receiver to the transmitter and vice versa. The remote position is used to provide remote operation of the radio facilities. He then turns the test key to the on position and holds it there until the tuning indicator light comes on. When it does, the antenna is loaded. The receiver is then manually tuned to the same frequency. He is now ready to make a preliminary call.
Alpha Alpha 8. This is Alpha Bravo 3. Over.
Alpha Bravo 3. This is Alpha Alpha 8. Over.
Alpha Alpha 8. This is Alpha Bravo 3. I have a radio teletype message for you. Over.
This is Alpha, Alpha 8. Send your message. Over.
The operator inserts a pre-cut tape into the transmitter distributor. He then places the send, mark hold, receive switch in the send position. He makes the necessary switching arrangements on his page printer and sends the teletypewriter message. The ANGRC 46 should serve to handle almost any teletypewriter traffic problem thanks to the flexibility provided by the two teletypewriters. For in addition to the page printer's ability to transmit and receive, there is the reperforator's ability to record incoming traffic on tape. Messages typed on the reperforator are also recorded on tape. The taped messages can be transmitted immediately. They can also be stored for later transmission. This ability to record a message on tape is advantageous in situations where a message must be repeated to several addressees. The operator of the ANGRC 46 has other responsibilities in addition to the actual operation of the equipment. Operator maintenance of the wire mesh filter in the T195 transmitter must be accomplished daily. After removing the cover, the filter is removed by unfolding the wire handles and pulling straight out. The transmitter should never be operated without the filter, 3 of which are provided, 1 in use and 2 spares. Instructions for cleaning and lubricating are printed on the side of the filter and should be rigidly adhered to. He must protect himself by always seeing that this protective rubber cover is securely mounted over the antenna binding post. Contact with the antenna circuit can result in severe RF burns. The functional components you see here are used in several different models of radio teletypewriter sets. The ANGRC 46 utilizes this S89C shelter made of steel and weighing 1,400 pounds. The ANGRC 46A utilizes this lightweight shelter made of aluminum and weighing 1,175 pounds. The ANGRC 46B utilizes this S144 shelter made of aluminum and weighing 1,110 pounds. This B model is particularly designed for use with online cryptographic equipment. In the ANGRC 46B are the usual racks to accommodate the equipment on the far wall, and these additional racks on the left wall which accommodate a security device and security files. When mounted in an armored personnel carrier, the equipment is called the ANVRC 29. This is the radio transmitter T195 GRC 19. It is here because we have an important point to make. Let's remove the case from this T195 and look inside. For ANGRC 19 operation, one cable goes to the exciter subchassis. The other connects to the rear of the front panel. Modifying the transmitter of a GRC 19 for operation as the transmitter of an ANGRC 46 is accomplished by reversing the connections of these two cables. It can be performed in a matter of minutes by maintenance personnel. This film has offered orientation in the components, capabilities, and operation of the radio teletypewriter set ANGRC 46. More detailed information concerning the correct tuning procedures and proper maintenance of this equipment can be obtained from the various manuals provided for the unit and its components. The ANGR C46 can transmit and receive traffic by continuous wave, voice, teletypewriter over a reliable distance range of 80 kilometers. It can provide simultaneous voice and teletypewriter operations, and it can offer these facilities in a mobile package, for it is one of the smallest radio teletypewriter units available for tactical communications. It is a valuable piece of equipment, one with which you should be thoroughly familiar, one which deserves careful attention to operation and maintenance procedures.